Hello everyone. Let's look at this problem that involves interpreting graphs. The question states, a nurse recorded patients' temperatures at different times of the day. Her measurements are shown in the graph above. So if I look at the graph above, on the x-axis or on the horizontal axis I have the days along with the times, and on the vertical axis or the y-axis I have the temperature in degrees Celsius. If I'm interpreting this graph, I can see that on day 1 the temperature of the person was 40 degrees. During the course of day 1 the temperature then decreased and thereafter increased, and at day 2 or on day 2 the temperature of that person decreased. So let's look at the first question, which asks how many times a day was the patient's temperature taken. This question, you just got to look at the times at which the temperature was taken. So for example, if I am looking at day 1, it was taken at 6 o'clock, 12 o'clock, 4 o'clock, and again at 12 midnight. That gives me a total of 4 times a day the patient's temperature was taken. Next question asks, what is the difference between the highest and lowest temperatures? In mathematics, whenever you are asked the difference, it usually means that you need to subtract something. So they have told us that they want us to subtract the highest and the lowest temperature. So to find the highest temperature, you look at the temperature values on the y-axis or on the vertical axis, and you look at the highest point that's there. If I look at the highest point, I will see that I have 2 points which have the same value, and that's 40 degrees Celsius. So my highest is 40, and the lowest temperature, if I look at the lowest point is somewhere there, and that matches up to 37. So the difference between 40 and 37 is 3 degrees Celsius. The final question asks, the normal human body temperature is 37 degrees Celsius. On what day was the patient's temperature normal? So to answer that question, you look for the temperature at 37 degrees Celsius on the vertical or y-axis. We have already found that here. So you extrapolate, or you just follow the line that's there. Once it touches the graph, you pull it down to the x-axis and it will tell you the day. In this case, it was day 2. Alright, let's look at another problem. Tani cycled from her home to town and back for shopping. On her way back, she stops at the filling station to have her bicycle wheels checked. Below is a graphical representation of her journey. So between 0 and 10 minutes, I can see that the distance from her home increased. From 10 to 40 minutes, the distance from her home stayed the same. From 40 to 44, 45 degrees Celsius, 45 minutes, between 40 and 45 minutes, her distance from home decreased, which means she's coming back towards home. From 45 to around 55, the distance from home stayed the same, and from 55 to 65 minutes, the distance from home came back to 0, which means she came back home. So the question asks, so the first question, how far is Tandi's home from town? So from town, it says that she went from her home to town. So the distance from home, so at 0 she's at home, and the town is the furthest distance away. So that distance is 6 kilometers. Question 2. How long was she away from home? So the whole time it took her to go from home to town to the filling station and then back home, it took her 62, 64, 65 minutes. So she was away from home for 65 minutes. Because remember, she left home at this point, she traveled, she stayed at that same distance, and then she started returning home. That whole trip took her 65 minutes, so just over an hour. Question 3, how long did she stay at the filling station? Okay, so we need to break this down now. So from home to town, it took her 10 minutes. And we can assume that she remained at town or in town for this duration. So from 10 to 40 minutes. So this is the time that she was in town for. When we read the paragraph above, it says on her way back. So on her way back, so meaning after this point, she stops at the filling station to have her bicycle wheels checked. So she is returning home, so she's getting closer to home, and then she stops at the filling station. And we know that this is the place she stops at because the distance from her home is staying the same. So to work out that time, we have to pull down the values. So that's 42, 44, that's about 45 minutes. And there is about 52, 54, around 55 minutes as well. So she was at the filling station for 10 minutes. Right. Let's look at the final question, the final problem here. This graph is a graph showing the number of tourists visiting South Africa and the number of jobs created because of the tourists visiting South Africa. Okay, the number of tourists visiting South Africa is on the x-axis and number of jobs created is on the y-axis. So the first question asks, how many jobs are created if 80 tourists visit South Africa? So the number of tourists visiting South Africa is 80. They want to know how many jobs are created. So to get this answer, we need to pull this point up, and when it touches the graph, we're going to pull it to the left to get the number of jobs created, which is going to be 16. Next question asks, how many tourists have visited if 12 jobs are created? So in this problem, they've given us the number of jobs. So the number of jobs is 12. So we have to go to the right. When it touches the graph, we bring it down. So the number of tourists is 60. Draw up a table of values from the information shown on the graph. So if you want to draw a table, we will put down the x values, or in this case, the tourists, and below that we'll have the y values, which are the jobs. So we will say 10 tourists, 20, 30, 40, 50, 60. We'll go up to 60. The jobs then created will be 2, 4, 6, 8, 10, 12. And of course it will continue. So this is our table. Next question, write an equation to represent the relationship between number of tourists, in brackets n, visiting South Africa and number of jobs created. So to answer that question, we have to look at the relationship from the table we've just drawn. So the number of jobs depend on the number of tourists that are there. So y, or j in this case, is equal to some function of the tourists, so some function of n. So to get this answer, we look at what do I do for to get 10 to 2. The number of things I could do. I could say 10 minus 8 is 2. I could say 10 divided by 5 is 2. Now we need to find the rule that will apply to all of them. So if I look at 20 tourists, if I use the first rule and I subtract 8 from it, I'm not going to get 4. So the first rule is out. So that leaves me with the second rule. So you take the number of tourists and you divide it by 5. And you can check the answer to see if it works. 30 divided by 5 is 6. That will work. 40 divided by 8 is 40 divided by 5 is 8. That also works. 50 divided by 5 is 10. That also works. So you find the function, you find the rule that works for the table that you've just drawn up. Final question, do you think the points should have been joined by a solid line? Give a reason for your answer. In this problem, they are asking us whether this is a discrete, so you must know what a discrete or continuous graph is. So should the points been should they have been joined by a line as shown? The answer is no. It should not have been joined. And the reason it should not have been joined is because the number of tourists have to be a whole number. And that basically means is that the number of tourists need to be counted. For example, I have 10, 20, 30, I may also have 35, 40, 50, 60 and so on tourists. If I have a continuous line, it could mean that I have a rational number. I can't have 5.5 tourists. I can't have 16.5 tourists. I can't have a fraction of tourists. So a continuous line would mean that I could have a rational number of tourists, which means I could have a fraction number of tourists, which is incorrect, because since I'm counting them, I'm counting the tourists, they need to be a whole number of tourists.